Hello, I'm Dr. Kim Yong-jin, OSTEM's representative digital guided surgery system is OneGuide system, which is easy to use and very accurate guide system. But if you are using it for the first time, it is a little bit hard to understand and unfamiliar. So in this lecture, let's understand and how to apply it clinically the OSTEM's OneGuide system. First, the OSTEM's digital guide surgical system, the OneGuide system. To understand it, we need to understand the characteristics of OneGuide template, and using the template, we can place implants using the OneGuide kit to clinically apply it easily. First, let's look at the characteristics of OneGuide template. The first characteristic is that it doesn't have a metal sleeve. The surgical guided system would be divided into two categories. One has metal sleeves and the other one no sleeves. Personally, I prefer a surgical stent without sleeves because when we use a high-speed drill, due to friction between the sleeve and the drill, the metal sleeve can be ground off, which is a side effect. Because of that, the metal sleeve's debris can go into the drilled site, causing infection and osseointegration failure. So when you use sleeve system between the drill and the metal sleeve, as it is drilled in high speed, the metal sleeve can be ground off and the debris can go into the drilled hole into the alveolar bone. It can cause infection or failure of osseointegration where implant is placed. A resin guide without a metal sleeve can also have resin ground off, but resin itself is a very light material. With irrigation, they can be sufficiently drained out. Second, we can encounter a situation like this. As you know, the surgical template, the stent itself is printed using a 3D printer. A metal sleeve cannot be printed, and metal sleeves need to be inserted into the template by a surgeon or a lab technician. During the positioning process, error can occur and special adhesive is not used, so mechanical method is used for the retention. So the metal sleeve can fall out or deviate from the position. On the repetitive drilling, if it is tilted or deviated from the position, another error can be introduced. Due to these reasons, I do not like to use the metal sleeve system. Still, many doctors believe that the metal sleeves can increase the surgical template's accuracy. Maybe it is because of the novel guide system, which is the beginning of the digital guide system, had metal sleeves. So most people believe that the system is very accurate. This is a comparison of metal sleeve system and the OneGuide surgical template, which is sleeveless. And the paper is published. Here, the OneGuide template is used. Generally, the OneGuide template that we use and the special OneGuide template where metal sleeve can be inserted, TS3 OSTEM implants were placed. Of course, OneGuide kit is used for surgery. 4 parameters are used to measure the implant's deviation. The one with the metal sleeve and the template without metal sleeve were assessed in terms of accuracy of implants placed based on pre-operational plan. As we expected, the system with metal sleeves had much more vertical positioning errors and angular deviations. As I said before, in positioning the metal sleeve, when it is not inserted accurately, the vertical positioning of implant position can have deviations, as you saw in the previous video. When the metal sleeve is tilted, when the guide is used for drilling, the drilling angulation will be changed, so the angular deviation of the implant can be caused. So you'd better forget the idea that digital guide surgery with metal sleeves can increase the accuracy. Ostem's OneGuide system adopts the metal sleeveless design. There are two types. Lateral open type is enabled when a patient has insufficient mouth opening, and through the guide hole, when drilling is done and implant is placed for the most posterior tooth, the lateral open design guide hole can be used to remove the interference of the opposing tooth. So this is one option that we can choose depending on the patient's capability to open the mouth and the surgical site. When a patient's bone is considered to be very hard, the lateral open type guide hole can secure copious irrigation, so the bone heating can be reduced. So the sleeveless design has the lateral open type guide hole. That's an option, great benefit to clinicians. Another thing, when we understand digital guided surgery, the concept of offset is very important. We can adjust the implant positions using the positions of guide holes. The angulation of guide hole can be controlled to control implant's angulation, but the vertical position of an implant can be controlled using this concept of offset. An offset is the distance between the planned implant top to the top of a fabricated guide hole on the planning program. There are various offsets depending on manufacturers. Many doctors believe that the offset is the thickness of the guide hole. It is not so. It is from the planned implant top to the top of a fabricated guide hole. So depending on the amount of subcrestal installation and thickness of gingiva over it and the thickness of guide need to be all added together to be the offset. When gingiva is thick, the guide hole should be made thinner. The offset should be the same. If I want to place an implant 1 millimeter subcrestal or deeper than that, the guide hole thickness should get thinner. Ostem's OneGuide system is always 10.5 millimeters in terms of the offset. That is, the thickness of guide hole can be adjusted to adjust the vertical position of an implant. So that is based on offset, which is always 10.5 millimeters for Ostem's OneGuide system. Some companies provide the offset options 9, 10.5 or 12 millimeters. When gingiva is thick, or when you have to place very deeply, or the crown of an adjacent tooth is very long, to avoid the interference from the adjacent teeth, offset needs to be set high. But in actual clinical situation, depending on the offset, the drilling depth should be varied. The tapered body implant, when it is placed, if you have different drilling depths, the osteotomy site and implant cannot be coordinated, especially in soft bone. So I believe consistent one offset is better than varied offset, especially when you are not familiar with digital guided surgery. Using a system with one consistent offset would be better. I've talked about the characteristics of OneGuide template. Let's move on to the OneGuide kit. When we drill or place an implant using OneGuide template, we use this OneGuide kit. There are many drills in here, and you may think it's complicated. If you understand it, it's quite simple. There are two parts in the OneGuide kit, the right part and the left part. Why are there two parts? F3.5 by 7mm long drills. There are two drills with the same diameter and length. There's another secret that I haven't mentioned about the OneGuide template. The guide hole diameters of OneGuide template has two types, 5.1 and 5.8 millimeters. There are two sizes for the guide hole diameters. For implants with a diameter of 4.5 or less, naturally, 5.1 diameter guide hole is formed. When we place 5.0 implant only, 5.8 diameter guide hole is formed. If you place a 5.0 diameter implant using 5.1 guide, the gap between the implant and the guide hole is too tight, and the implant can touch the inside of the guide hole. So there are two types in the size. So when you drill using the 5.1 diameter guide hole, 4.5 or smaller diameter implants, you can choose the tools from the left part. If you want to place an implant of 5.0 using 5.8 diameter guide hole, you can choose the drills from the right part. So all the drills on the right part has the marking of W. That means the drills are for wide guide holes. All the drills and surgical tools in the OneGuide kit have guide barrels that can be guided through the guide hole. The barrel size differs depending on the diameters of the guide holes. Tissue punch. The drill is used to remove the entry point in the soft tissue. I use it selectively only when gingiva is very thick. Gingiva is thin, I drill the bone directly. Next, initial drills. The difference between the 1 to 2 taper kit and taper kit and the OneGuide drill lies in the initial drills. In the OneGuide kit, there is no side cutting drills. Initial drill has multiple steps. In the 1 to 2 taper kit or general taper kit, lens drill or side cutting drill are used as initial drills. But in the Ostem's OneGuide kit, there are multiple drills for the initial drilling, including the wide dimension. The drilling depth is up to 5.7 millimeters. Flattening drill. In the OneGuide kit, it is included, but it is not included in the tapered kit. When we place an implant accurately as planned, we need to use this flattening drill in the OneGuide kit. Let me show you when to use it. It looks like this. All the drills in the OneGuide kit have stoppers. You need to drill until the stopper touches the top of the guide hole, like this. You may think it's obvious, but not always so. When we place an implant very deeply subcrestally, when the buccal or linguoalveolar bone has a very big height difference, or mesial and distal bone height is different, the drill may be stopped by the higher bone, especially the bevel part. The lower arrow indicates the bevel part of the initial drill. There's no cutting edge in the bevel part. So when the bevel part touches the crystal cortical bone, the drill cannot move in anymore. Then the stopper of the initial drill cannot touch the top of the guide hole. No matter how much force you may apply, it cannot move in any longer. In that case, you cannot force it to move in. So flattening drill is used. So when Junjaba is thin and when the depth of placement is deep, like 1.5 millimeter or deeper subcrustally, or deep placement is planned to avoid the inclined plane, flattening drill needs to be used. If you use the initial drill again after the flattening drill, the crestal cortical bone interference is removed, so initial drill can go to the full depth easily. So flattening drill needs to be properly used. Next is the OneGuide drill, used for the final drilling to place an implant. Most of the drills in the OneGuide kit are the OneGuide drills. They look like this. The OneGuide drill looks similar to the drills in the 122 taper kit, except the guide barrel that guides through the guide holes. The characteristics of OneGuide drill is that it is tapered. The cutting efficiency is superb. If you compare it to other companies' drills, some are straight at the apical and tapered in other areas and tapered drills. But OneGuide drill is tapered and it has multi-steps, as we already experienced with the taper kit or 122 taper kit. It has a very high efficiency in terms of cutting. I believe I don't need to explain any further regarding the efficiency of cutting. Due to good cutting efficiency, heat is less generated. Compared to straight drill, tapered drill would facilitate irrigation, easily drain out bone debris, generating less heat. So the drilling sequence can be made very simple due to efficient cutting. So up to 4 times drilling is sufficient to place an implant with OneGuide kit. But if you use other companies' straight drilling system or straight and tapered combination drills, up to 10 drilling sequence is required. Let's compare them. OneGuide drills can be used in the same speed as the drills in the 122 tapered drill at 800 to 1500 RPM. Straight drill system generates a lot of heat, so they recommend low-speed drilling below 50 RPM, which lengthens surgical time. So if you look at system B at the beginning, the drilling depth is increased only. 2.2 initial drill increases the length 7 to 8.5 to 10 millimeter until the ultimate depth, and the diameter of the drilling is expanded gradually, which is complicated, but with the OneGuide system, maximum 4 drilling is required to place an implant. When we use a OneGuide kit, in placing an implant, the drilling sequence is the same as the 122 taper kit drilling sequence. The basic drilling sequence of 122 taper kit, in normal bone, diameter of an implant to be placed is the same as the number on the final drill. For soft bone, 1 step smaller. For hard bone, 1 step higher. The same for the OneGuide system. So if you want to place an implant 3.5 millimeter diameter, initial drill is used, and you can go to 3.5 drill, F3.5 OneGuide drill in normal bone, but in soft bone you should under drill. So 2.2 diameter straight type twist drill is included. A 2.2 diameter straight twist drill is not needed in general cases. 3.5 millimeter TS3 implant can be placed with under drilling in soft bone. An initial drill has F3.5 initial drill for soft bone. to under drill. So F3.5 soft initial drill is used not to excessively remove the cortical bone at the top of the crestal bone for under drilling. For normal bone, after using an initial drill, F3.5 up to F4.0 oversized drilling can be used. That's why 2.2 diameter twist drill is included. What about when we place 4.0 TS3 implant? Initial drill is used if the bone is considered soft. Up to F3.5, OneGuide drill can be used before placing an implant. For normal bone, F3.5 and then 4.0, F4.0 OneGuide drill can be used. If it is a hard bone, one more drill up to 4.5 can be used. What about placing 4.5? After initial drill, F3.5. If it is soft, F4.0 can be used. For normal bone, after F3.5 OneGuide drill, F4.5 OneGuide drill can be used before placing an implant. What about hard bone? Oversized drilling should be done. Up to F5.0 drill should be used, which is impossible because for 5.0 diameter implant placement, the guide hole itself has the 5.8 millimeter diameter, so F5.0 OneGuide drill would have a 5.7 guide barrel, which cannot get in. So for 4.5 diameter TS3 implant to be placed in hard bone, cortical drill is included in the kit. F4.5 cortical drill is used to place a 4.5 diameter implant in hard bone to expand the crestal vertical bone. For placing 4.0 or 3.5, the next step drill can play the role of the cortical drill. So F4.5 cortical drill is only for 4.5 diameter implant. Placed on 5.0 implant, the initial drill should be chosen on the right part. 5.0 implant is planned, then guide hole is 5.8, so initial drill with W mark should be chosen, and then F3.5 W OneGuide drill. If it is soft bone, up to F4.5 W drill. Up to that OneGuide drill can be used to place an implant. For normal bone, 5.0. If it is a hard bone, F5.0 cortical drill can be used. This is the concept for drilling. Other companies attack us like this. This is the Austin's Digital Center fabricated OneGuide template, and the OneGuide drill is used for the testing. It is moving, shaking. If you look at the gap between the OneGuide drill and guide barrel, it's only 0.1 millimeter, which is a small number or big depending on the perspective. It can cause angular deviation, but some people say it is inaccurate because it doesn't have metal sleeves. And one thing is overlooked here. If we do the initial drill accurately, the final drill, if you use OneGuide final drill, this happens. In the previous video, the drill's apex is not in contact with bone, so the guide hole is in touch with the guide barrel only, and the apex side of the drill is not fixated. However, if you do the initial drilling accurately, and if you use a OneGuide drill as a final drill, the apex area is in contact with bone. So this is called a double contact concept. So you do not need to be worried about that in a clinical situation. So initial drilling is very important. So the apex of the drill does not touch bone, so it can move like this. Only guide barrel is in contact with the guide hole. So inside of the guide hole is in contact. So initial drilling should be made very accurately. So the initial drill should be inserted without the rotation. until the barrel of the drill is in contact with the inside of the guide hole. After that, you need to step on the paddle for rotating it. That is how to use the initial drill accurately. So after final drilling, we need to place an implant using the no-mount driver. For guided surgery, no-mount driver is used to place an implant. And using the handpiece, the implant is placed. After that, the hex positioning and the depth control can be made using the fixture driver. When the top of the fixture driver is in line with the top of the guide hole, the implant depth is proper in terms of vertical level. Using the yellow slot in the guide hole, the hex positioning can be achieved when the yellow color is showing through the slot. This means it is not fully inserted. This one shows it is properly seated. Once again, this is not properly hex positioned. Using a handpiece to do precise hex positioning and the implant depth adjustment. So we can use a fixture driver for positioning. So 80% is placed with a handpiece and the rest is adjusted using the fixture driver for depth control and hex positioning manually. So hex positioning and depth control is done simultaneously like this. In a free end case, or if there is a very few teeth remaining, or in edentulous case, surgical template is stabilized using the anchor tools. In other companies' systems, anchor tools need to be purchased separately, but in OneGuide system, in the kit, 3 anchor pins and dedicated anchor drills and anchor drivers are included. No need to purchase them separately. Up to now, we have looked into the OneGuide surgical system of Austin. OneGuide template has the characteristic of no metal sleeves. A lateral open type can be designed, which enables copious irrigation during surgery, and interference of opposing tooth can be avoided. This is a very good system for both surgeons and patients. And this OneGuide kit adopts very efficient cutting system, as you've seen in 1 to 2 taper kit or taper kit. So even under high speed, the heat is less generated and the release sequence is made very simple. Using a OneGuide system, even beginners can place implants in a good position very accurately, increasing the level of satisfaction on the part of patients. Not only that, a long-term prognosis of implants would increase. However, if you use a digital guided surgery just blindly because it is a trend, you can get confused and you may distance yourself from the digital guided surgery. I hope this lecture has been helpful for you to understand the benefits of OneGuide kit and OneGuide surgical template. I hope you enjoy easy placement of implants. Thank you for your attention.